welcome to Season. Today we'll be talking about polyacrylamide gel electrophoresis and agarose gel electrophoresis. Let's dive in.
On the polyacrylamide gel electrophoresis, point 1. Prepare and load samples. Prepare your samples, which may involve denaturation with chemicals like SDS for protein or urea for nucleic acid. Load your samples and a molecular weight marker, a ladder, into the wells of the gel using a micropipette. Be sure to load the marker in one of the outer wells. For accurate loading, stabilize your arm and position yourself at eye levels within the wells.
Mount the gel assembly into the electrophoresis tank. Ensure the short place is facing inward. Pour running buffer into the inner chamber followed by the outer chamber, making sure the bottom of the gel is submerged.
After assembling the apparatus, we now run the gel. Point 1. Place the lid on the tank and connect the power supply, matching the red and black electrodes correctly. 2. Plug in and turn on the power supply. Step 3. Set the voltage and press run. And now further explain. The optimal voltage and time will vary depending on the gel and samples, but a common method is to run it at a constant voltage until the die front is near the bottom of the gel. Some protocols suggest starting at a lower voltage for the stacking gel and increasing it once the protein enters the resolving gel.
How to prepare the gel and the tank? Step 1. Place the solidified Agarose gel into the electrophoresis tank, making sure the wells are on the side of the negative electrode. Step 2. Pour enough buffer solution into the tank to completely submerge the gel, typically until the wells are covered by a few millimeters of liquid.
Load the sample. Add a loading dye to DNA sample. The dye contains glycerol to make the samples heavy so they sink into the wells, and a visible dye to trap the run. Secondly, using a new pipette tip for each sample, carefully pipette your DNA sample into wells. Third, steady your hand by resting your elbow on the table for precision. And lastly, load a DNA ladder into one of the wells to serve as a reference.
Run the gel. Place the lid on the gel box. Connect the lid from the gel box to the power supply, ensuring the black negative lid from the box connects to the black terminal on the power supply, and the red positive leads to the red terminal. Point 2. Set a constant voltage, example 80 to 150 voltage on the power supply. The appropriate voltage and time will depend on the gel's concentration and the size of the DNA fragments you are separating. Point 3. Turn on the power supply to begin the run. You should see bubbles rising from the electrodes as the electric current begins to flow. Point 4. Run the gel until the load dye has migrated about 75% to 80% the way down the gel.
Analyze the results. Turn off the power supply and disconnect the leads. Remove the gel from the chamber and drain excess buffer. Visualize the DNA branch using a gel documentation system. The DNA will fluoresce under UV light. Visualize the DNA branch using a UV transluminated or gel. Visualize the DNA branch using a gel documentation system. The DNA will fluoresce under UV light. Wear appropriate UV protection for your skin and eyes. Then you document the results by taking a picture of the gel.
Thank you for staying with us to the end of the video. Like, share, subscribe. Bye!